Welcome to Excellencia School of Chemistry, discussing the practical examination of this year's WAEC with you when it comes to chemistry. And the one we're looking at now is the volumetric analysis. The likely question is, it might go like this. A is a solution obtained by dissolving 25.4 grams of an impure sample of iodine in aqueous potassium iodide, and the solution made up to 1 dm³. B is a solution of 24.8 grams per dm³ of sodium thiosulfate. Now the instructions: A, put A into the burette and titrate it against 25 or 20 cm³ of B using starch solution as an indicator. Repeat the titration until you obtain a concordant titer value. Tabulate your results and calculate the average volume of A used. The equation for the reaction is as given here. And then we have B. From your results and the information provided, calculate the I, the concentration of B in mole per dm³, II, the concentration of A in mole per dm³, III, the concentration of A in gram per dm³, IV, percentage by mass of iodine in the sample, and V, number of thiosulfate ion in 250 cm³ of the solution. C, give reason why the starch indicator is added to the titration mixture at the beginning of the titration. So the volume of pipette used here is 25 cm³, and then you titrate it like this. You put the iodine solution in the burette and pipette 25 cm³ of the thiosulfate solution into the conical flask. You add some drops, maybe 5 drops or even less, of iodine solution into it. I prefer using a boiled starch because it's more sensitive. And we titrate it. The endpoint is observed when you have a permanent blue-black color. So it is tabulated like this. Make sure you present it like this. You also have your unit. You present it in 2 decimal places. The second decimal place should either be 5 or 0. And of course, it is going to be final reading up, then initial reading down, because you are subtracting. So here we have the average volume of A used as shown on the screen. The average, you add up the 3, first titration, second titration, and third titration, and divide by 3. You present your average volume of A used in 2 decimal places. Table. There is a table as it should be. Yes, well presented and with the unit correct. So we now look at the solutions. The first one, the average volume of A used. We sum up the first titration, the second and the third, and divide by 3. And the answer there is 41.08 cm³. You present in 2 decimal places. Now the molar concentration of A, molar concentration of B rather, and the formula for molar concentration is mass concentration divided by molar mass. And we find the mass concentration, we find the molar mass as shown here. You have to show your solution for the molar mass. And then we find the molar concentration, mass concentration, that is 24.8 as provided in the question, over the molar mass, which is 158 grams per mole. And the answer is 0.157 mole per dm cube. It must be presented in 3 significant figures. II, that is finding the concentration of A in mole per dm cube. We use the formula CAVA over CBVB equal to Na over Nb, which is the mole ratio of A and B as provided in the question. So we make Ca the subject of formula before substituting, as we see above here. So making Ca the subject of formula and substituting, we have Ca to be 0.0478 mole per dm cube, still in 3 significant figures. Next is the molar concentration of A. Now, still using the formula, molar concentration is equal to mass concentration over molar mass. And the molar mass of A is 2 times 127, which is the relative atomic mass of A, of iodine. So making a molar mass concentration the subject of formula, we have it mass concentration is equal to molar concentration, as we've already solved above, times molar mass, which is 254 times 0.078, and the answer is 12.1 gram per dm cube. And next is the percentage by mass of A in the sample provided, and that is the percentage purity. We use the formula mass concentration as we calculated above over mass of the impure sample, that is the sample provided, times 100 over 1. It gives us 12.1 over 25.4 times 100 over 1, and that gives us 47.64%. You present it in 2 decimal places. Now, the next point in our discussion is the number of thiosulfate ions in 250 cm cube of the solution. Now, from our calculation already, we have found out that 1 dm cube, which means 1000 cm cube, contains 0.157 moles of thiosulfate ion, which is the molar concentration of B. Therefore, 250 cm cube would contain 250 times 0.157 over 1000, which is 0.03925 mole of thiosulfate ion. And going by that, we make a statement that 1 mole, of course we know 1 mole of any particular substance contains 6.02 exponential 23 particles. Therefore, 0.03925 mole would contain 0.03925 times 6.02 exponential 23, which gives us 2.363 exponential 22 thiosulfate ions. Now, the next is to give reason why the starch indicator was added to the mixture at the beginning of the titration. It was added at the beginning of the titration so as to indicate the point at which all the thiosulfate ions have been completely oxidized by iodine, at which point any further drop of the iodine would see the iodine forming a blue-black complex with the indicator. Thank you very much, and watch out for our next post, our next video on qualitative analysis. But meanwhile, make sure you subscribe to this channel so as to get promptly videos on chemistry. Thank you. This is Excellential School of Chemistry.